All right, let's do it. Okay, so we're going to talk about, the title of our talk is Catch Me If You Can, Ephemeral
Can they hear us?
Can you
They
guys
can't.
hear us?
Yeah.
Are the mics on?
Yeah, 1 sec.
Is that better? Yeah, you guys can hear me?
Can you guys hear me?
Yeah, sweet.
Perfect.
Okay, cool. All right, so the title of our talk is Catch Me If You Can, Ephemeral Vulnerabilities in Bug Bounties. So my name is Gianarakis. I'm CEO of Asset Note. Formerly I was with Spider Labs in Asia Pac. I've spoken at a bunch of conferences, so maybe you'll see me from there, mostly in mobile security. I'm the organizer of a couple of meetups and a conference in Australia, which is much less organized than 44Con, much more. Yeah, go Tuskon, thanks man.
So I'm the CTO of Asset Note. I used to work as a senior security analyst at Bishop Fox. I'm a part of the HackerOne Top 50, and I'm the co-founder of Hackers Helping Hackers.
So you want to give a quick spiel for Hackers Helping?
Absolutely, absolutely.
It's a really good charity.
So Nathan and I co-founded a charity in Australia where what we do is we take money from a bunch of sponsors within the InfoSec space and we redistribute it to hackers that actually need help in education and getting into this industry. So students who have just basically, gotten to a point where they have no idea how to break into the industry, we take them, send them to conferences, pay for their flights and accommodation, and train them up throughout a year. So if you want to check that out, definitely do and hit us up if you want at any point.
Cool. All right, so what are ephemeral vulnerabilities? So put simply, ephemeral vulnerabilities are vulnerabilities that exist in an application system for a short period of time, right? Usually a matter of hours or days. So straightforward, yeah? So why do they exist? Why is this a problem? How common are they and what is the impact? And is this a real thing or are we just a couple of Aussie wankers trying to come up with fancy names? The answer to that hopefully is no. You can be the judge of that. So just to set the scene, take a step back, let's start with bug bounties. So a few years ago, there was a shift that introduced a new form of security assessment on a large scale, bug bounties. Bug bounty platforms, like BugCrowd, HackerOne, packaged up to the sort of the internal bug bounty model and productize it for many companies who hadn't, and in a lot of cases probably wouldn't have run a bounty before. And the bug bounty model, and more specifically, the reward-based economic model that underpins it, has kind of shifted the behavior in the way that people are testing applications. If you aren't successful, you don't get paid. That's the kind of the approach. And if you approach bounties like a pen test, you won't be successful, at the very least, not on any real scale. And I think Shubs will agree with me, it's absolutely fair to say that most of the innovative techniques and tools in web application space in recent years have been born out of the bug bounty space. So bounties are not pen tests.
Yeah, so essentially bounties are not pen tests. They differ in so many ways. In a pen test, it's normally point in time. It's usually 1 to 2 weeks. It's tightly scoped. It's typically a static scope, so you have a list of IP ranges or subdomains that you're explicitly allowed to go after and nothing beyond that. You pen test new projects and then it's business as usual. It's performed in some sort of test/non-production environment, something that's in either QA or something that's not actually having, it doesn't replicate the pure production environment. The standards and methodology is, it's driven on, it's focused on coverage and it usually is compliance driven. A lot of pen tests are quite frankly done for a checkbox. Alternatively, on the flip side, you've got bug bounties where it's kind of the opposite. It's ongoing. It's typically broader scope, so although there are limits, it's evolving. So every time you're testing it, things have changed and it's not point in time. Your scope that you're going after has changed from what it was yesterday and then the day after and the day after, day after. It's evolving very quickly.
And as we'll hopefully demonstrate, sometimes it's evolving on an hourly basis.
Yes. And in bug bounties, it's performed in production, which is kind of scary for a lot of people, but I really do think that's the best way to do security testing when you're looking at something at that scale and to find all the actual bugs. It's results driven, only pay and get paid on results. Have to be first to get that result. And this one's actually super important because in my opinion, I think that bounties have, you see a lot more innovation in bounties because of the fact that it is result driven. People aren't going to be making tools that aren't going to be making them money in bounties. That's a waste of their time. Bounty hunters who do it full time, like myself for some time, Nathan and so forth, many other bounty hunters that do it full time, You can't invest your time in creating tools and software if you're not going to get a return from it, because that is your income. And usually it's security driven. It's not as much of a compliance focus. So if you want to be successful in the bounty space, you can't just approach it like a pen test. You have to approach it like a competition. And you are competing with everyone else to find new bugs that actually have a security impact before anyone else does. And in this sense, when it comes to competition, I think it's super healthy, because that is what actually breeds the innovation in our bug bounty industry. So if you're not first, you don't get paid. No actual security impact, don't get paid. X technology stopped you, sucks to be you, you don't get paid. For us, if we're spending time doing computer stuff instead of drinking beer, we want to be paid for it, essentially. So getting paid.
Yeah, so over to me. Yeah, sure, all right. So yeah, we like getting paid to find bugs, but to get paid on any kind of decent scale that replaces sitting on a data center floor for 8 hours a day, you need to take a different approach. You need to cover all of the possible scope. If you miss something, you're missing an opportunity for a payout. You need to be fast. There's no prizes for second place in the bounty world. If you're second, that's great, but it's a dupe. Sucks to be you. It needs to be continuous. If you're not looking at things constantly, you will miss opportunities to be paid. Everything, modern application environments and modern attack surfaces are constantly evolving. And if you're not looking at this stuff continuously, you're going to miss those opportunities. And you need to adapt to how organizations are actually developing their applications and deploying their infrastructure in the real world. So all of the protections that are in place, whatever technologies that they're using, you have to adapt to that, as opposed to just doing what you've always done. You need to keep up with it. So yeah, automating it. With an approach, with that sort of approach, but down those sort of principles, the next challenge was to scale. So we built a tool that will automatically find new assets in a given scope, check for bugs on a continuous basis. This is a tool that would essentially form the genesis of Astronaut, but that's another story. Come see us later if you want to find out. And by continuous, we mean performing all the recon and security checks at least every hour. This worked extremely well. Bugs were found, money was made, alcohol was consumed. It's great. But one of the interesting things that came out of building this tool is that shifting to a more of a continuous security approach as opposed to point in time presented a whole bunch of new opportunities that started to emerge from that. Do that.
So shifting the approach to a security assessment from point in time into a more continuous approach ends up morphing into much more of a monitor and respond approach. And I can totally testify against this. I used to be a tester who used to go through the application, find every application as a part of a scope, go through each one and take a look. But today, it's the other way around. I want to now be notified of what things I should be looking at. What are the indicators? What are the things that are on this huge scope that do deserve my time? I want to reduce the amount of time taken to find really good bugs. So this ended up having a number of benefits. It adapts to the organization and how they actually develop applications. So if I get notifications about a new subdomain that this organization has released, in the last hour or so, I might be able to tell, depending on the previous subdomains and so forth, what they're working on, or what's new, or what has changed. You can find bugs quickly, and you can find all instances of that bug across an organization. So if you have a really good idea of where all of your assets are located, and you have some sort of way of testing for a particular thing across all these assets, then that's actually, not only can that be used to test for remediation, like regressions, but it can also be used to test across a huge scope very quickly to find quick results. And ultimately, it leads to the ability to find ephemeral vulnerabilities. There's no money left on the table.
So this photo I put in the slide, this is how you'll often find Shubs. This is in the taxi on the way from the airport here, and he really embodies this monitor and respond approach. Anytime there's a ping from our tools, it's like straight on the laptop, doesn't matter where you are. So yeah. So just to, I can do this one, cool. So yeah, just to kind of visualize what we're talking about with ephemeral vulnerabilities and this whole idea of continuous assessment, you take this kind of timeline, right? This is an organization, they do a bunch of vulnerability assessments, different points in time. You do a bunch of pen tests, different points in time, and along that scale, things are changing, things are being developed. And then sort of in between is where you have these sorts of ephemeral vulnerabilities that you get because you're looking at it all the way along the timeline as opposed to just the points in time. So root causes of ephemeral vulnerabilities. So ephemeral vulnerabilities as a concept isn't necessarily a unique or new idea, right? Any bug can be ephemeral. That said, ephemeral vulnerabilities are, in our experience at least, becoming more prevalent. And you can't really pinpoint a single root cause based on looking for these bugs, but based on looking for these bugs across a number of programs and organizations, there are actually a number of elements that seem to be driving this increased prevalence of these sorts of issues. So these elements include cloud-first architecture, rapid development and deploy cycles, like DevOps is becoming more of the norm. Broad attack surfaces, so having lots of externally facing assets, and large organizations that have somewhat complicated internal structures. So I have multiple subsidiaries, often in different countries, different teams that have either development capability or budget to get things developed. Can be good indicators of where you're going to find ephemeral vulnerabilities. But really, ephemeral bugs are really just mostly down to the pace of change, complexity, and scale. Securing systems that are constantly changing across a large and complex attack surface, it's hard, right? I mean, we're going to show you some bugs today, and you look at that and think, wow, that's crazy, but these are very large organizations. It's really hard to do this at scale. And even just keeping on top of what assets you have on the internet at any kind of scale is a difficult challenge, even for very well-funded teams, let alone monitoring for security issues. At that scale and pace, mistakes happen. People screw up. Shit happens, basically.
So the impact, right? That's what matters the most about all of this. And the impact of ephemeral vulnerabilities is usually quite huge. The defining characteristic is that it happens in a short period of time that they're live. Ephemeral vulnerabilities is a short period of time that they're live. That means that the impact of these bugs vary because of the type of vulnerability. Any type of vulnerability can be ephemeral. That being said, the impact of these bugs tend to be pretty high because they're short-lived in nature and generally reflective of an issue that shouldn't have been there in the first place and they're fixed quickly. Now, I hope that I can really reiterate how important this is once I show the bugs that we found, because these bugs definitely are critical, and they're definitely bugs that were only there for short periods of time. Companies don't tend to fix things that have no real impact that quickly. So to help illustrate this, we have some examples, and we've submitted them to multiple bounty programs. They've all been paid quite a bit of money that's been resolved for quite some time, so we can talk about them today. We've got 3 examples to show you. 2 of them we can disclose completely, the company as well. 1 of them is slightly redacted. These bugs get paid out very well. So ephemeral issues are definitely things that I think bug bounty hunters should be looking for. And before we go through them, I think it's worth pointing out that all of these companies that we've worked with were an absolute pleasure to work with. We ended up resolving these issues quite swiftly, and we didn't have any complications throughout. So the first bug. The first bug I want to talk about is evaluating AMP script on Uber. So for quite some time, we knew about a subdomain called exacttargetweb-web-hook.uber.com, and it always returned something like this. And I've seen this page 1,000 times, and I've always been like, it's a JavaScript Express.js application, but nothing seems to be on it. I've done heaps of content discovery work, and I still can't find anything. So do I forget about this asset? Well, it was forgotten. And it was forgotten until we detected a change. And once we detected a change, it actually looked something like this one day. And that's a pretty dodgy looking application already. And if you take a look at it, it's got this iPhone, it's got this little message and all the details that, this whole thing is like, all right, I want to send a message to someone and personalize it. So that's what I picked up from looking at this page initially. This was served on the index page instead of that 404 not found that I showed you earlier. So now that we found this new functionality, we had to figure out where to go next. We tried interacting with the UI, tried making API calls while listening for requests, but it didn't work. All the requests failed. It returned an empty JSON response. So we then reversed the JavaScript. We recreated a legitimate API call and finally swapped out all of the Uber UUIDs, which is essentially like a unique ID that identifies you on the Uber platform with our own UUIDs instead of the ones that were provided on the front page that I showed earlier. And that worked. And that actually led to something super awesome. So I want to explain what it led to. So the API was working, and there was no output received when running the example AMP script shown on the front page of the app. That example AMP script, well, actually, so let's learn AMP script. And you might be asking yourself, like, what the hell is AMP script? WTF is AMP script? So AMP script is actually a part of Salesforce's Marketing Cloud. And they provide AMP script as a scripting language that they can embed marketing content within emails, SMSs, anything that needs to be dynamic. So what can AMP script actually do? Turns out it can do quite a lot. So if you take a look here, there's quite a lot of things you'd expect in basically any scripting language. They've got HTTP functions, encryption functions, data-related functions, all sorts of things. So let's try and use AMP script to create, use the HTTP functions within AMP script to see if we can get a call out, just to confirm whether or not this is actually a vulnerability we need to care about. So this was the syntax in AMP script to make a HTTP request to an arbitrary URL. And it worked. We got a response saying that this AMP script has been evaluated, and we've got the result of that, which is basically a full response SSRF here. You've got that it's actually coming from ExactTarget Inc. Now that was really interesting when I saw this, because that meant that the script that I was sending through and where it was getting evaluated, it was actually just getting evaluated on ExactTarget servers, not on Uber's servers. So we've proved that we can execute AMP script through Uber, but it's being executed on ExactTarget's servers. And that's where it gets interesting. It's like, how do we go further? And we found out that Salesforce Marketing Cloud allows you to pull data from a number of sources using something called data extensions. So data extensions are like database tables that can be accessed through AMP script's data extension functions. So this is the AMP script that we saw returned by the application itself. It looks something like this. It sets a first name by doing a lookup in a data extension and then prints that first name out when personalizing the message. So as you can see, it does like a lookup in that little data extension called driver_partners. So even though this AMP script query did not work, it had enough information for us that we could use it to create our own AMP script that could pull down data from the driver partners data extension. So this was the final proof of concept. This proof of concept, trust me, it was very hard to write AMP script. I didn't even know it existed until I found this bug. But this proof of concept is actually quite simple. It looks at the data extension called driver_partners, and it does a search. It does a search for everyone which has the first name Shubs. Based off that, it assigns some variables, and then it finally prints them out. And to our surprise, we gave this a shot, and it actually, it worked. We got a list of users that were registered on Uber, and a lot of their details, as long as their first name was Shubs, it printed it out. So essentially, this one bug that, one day it was just a 404 with no content whatsoever, and then the next day it turned into something this critical. That's because we were testing the day before and then the day after. Like we're continuously testing. We're finding these bugs in the gaps where there's development cycles, but there's no security testing done. There's a lot of development happening because there's thousands of engineers pushing out code to the cloud, but there's still no oversight on what's being pushed out at all times, or even just nothing to catch the gotchas, like simple network access control mistakes that often leads to very critical vulnerabilities.
And this being Uber, right? They would be doing some kind of security in development probably, but at the end of it, like we spoke about before with pen tests, they'll probably be doing a pen test before they deploy, and then doing sort of regular pen tests. But this was being actively developed, and this is why we saw it. Like it was just, as you saw, it was nothing there, and then we were just monitoring it, and it changed. So it's sort of demonstrating the value of like looking at things continuously. Okay, cool. So this is the one that was redacted. Hopefully, I do not screw up here, but we'll see. So breaking into large US e-commerce companies' CI. So we set up large US e-commerce company into our automated monitoring systems, and overnight it found the host, HTTPS Jenkins, TFS webhook, e-commerce company.com, and it was found to be running a publicly facing Jenkins instance. So it was overnight. We got up, having breakfast, chilling in the morning, looked at it, and saw it was a Jenkins machine. Had a cursory kind of look, but it required authentication, and no really serious bugs were found at the time. But we're going about our business, we're sitting in the afternoon drinking, as we do, and casually checking it out, and noticed that they replaced Jenkins with the Concourse CI application, but had not removed the DNS records for the Jenkins 2 TFS webhook at blah.com. So most accounts registered on their Concourse CI were accessible without any authentication. And this was a very recent change that was detected for the asset within a couple of hours. So again, like this is the kind of timescales we're looking at. And when you're continuously monitoring stuff and continuously looking at things, you start to be able to work at these timescales.
And something to mention here is that like the fact that they were changing from Jenkins to Concourse, and the fact that we found that there was no authentication required, I would dare say that if I checked that same Concourse CI in like a week's time, they might have actually set up authentication properly. I think what had happened is that we found them in the act of changing CIs completely, and they were working on that, but we had gotten to them before they had even implemented authentication.
Cool. So once we're logged in, we're able to view the CI pipelines. Here's some of the examples here. Hopefully, if anybody recognizes anything, don't say anything, please. So a bunch of CI pipelines. And so in order to react with the server, we downloaded the Fly CLI tool, which you can get from that URL, to start interacting with the CI. And this allowed us, most importantly, to read the config of existing builds and get access to the Docker registry. So we logged in using Fly, that's the command there. And yeah, so pretty straightforward. And then the most critical vulnerability was being able to read the config of existing builds, and that contained the credentials to the Docker registry, which are hopefully all redacted there. Yeah. Just checking, a bit nervous. They were pretty emphatic not to mention their name. So then we can log into the Docker registry using those credentials that we just found and get all these Docker images. Pretty straightforward. Yeah?
Yep.
And then using Docker, we decided to pull down the payments resource and then run the following commands, started exploring the container a little bit, and we found the main.go file. And in the main.go file, it contained the Azure Cloud Secret keys that were hard-coded into the source, which are there, like hopefully redacted. Yes, good. We did double check, but we've been drinking for a bit, so. So we were able, we're Australian, come on, like, give us a break. We were able to confirm that the keys works using the following commands. So logging into Azure, the keys were actually valid keys, and returned a list of assets. And we'd proven the keys work, which is a critical vulnerability, obviously, getting keys to their Azure environment. And at this point, no further exploitation was required, and we were paid $14,000 for the bug. So pretty great.
Good bug. And the final one, I think this one's actually quite a cool one, actually. It's also the reason why I quit my job. So one of the reasons why I quit my job. In January last year, I was considering quitting my job and going full-time to run a startup. And this was the bug that convinced me, that said, look, all right, ephemeral issues are valid, continuous security is a valid thing, and I need to explore it further. So it's about an exposed Git repository on Slack that led to all of their source code and their secrets being leaked. So just to set the scene, 10th December 2016, we set up our automated monitoring systems, and we look at everything which has an SSL cert related to Slack, and we look at we look at reverse whois data to find domains that are owned by Slack. Two very simple reconnaissance methods to find domains that are owned by Slack. We add them all into our automation systems, and these domains in particular look something like slack-reader.com, slack-files.com, and slack-core.com, to give you some examples. By using passive DNS data sources, our systems collected thousands of subdomains, but there weren't any vulnerabilities that were picked up immediately in December. Through automation, we kept on testing these subdomains that we picked up. We tested them every hour of every day from 10th of December until we finally found the vulnerability that led to the critical bug. So 14th of January 2017. For a short period of time, a Git repo is exposed which contains the source code for Slack's entire web application. This source code was 1.6 gigs. It had over 300 secrets hard-coded within the source code. This is how it looked like. qa30.slack-reader.com/.git/config. Now, what was interesting is that it wasn't just QA30 that was exhibiting this behavior on 14th of January. It was actually around 10 to 15 different QA subdomains that were ordered in numbers like QA 20 to 30 that were exposing this vulnerability. And it seems as if what had happened is someone who was doing DevOps or setting up a new staging application for Slack's main web app had cloned it to the web root but forgotten about the Git repo in the web root. So 14th of January, we used this tool to pull down this entire Git repo. It cloned it successfully in its entirety. And at the time, Slack's config.php file contained the credentials from multiple services, including Dropbox, Zendesk, Salesforce, Google OAuth, Twilio, Screen Hero, Stripe, Twitter, OAuth, Amazon AWS, Braintree, GitHub, Asana, Help Scout, Box, Wunderlist, and possibly more.
There were 300.
There were a lot of credentials there. And I feel really, really sad for whoever had to rotate all of them.
Yeah.
We reported this bug to Slack via HackerOne as soon as we confirmed the findings. And Slack were very quick, within hours, to remove the Git repo from the web root. You'd hope so.
Yeah.
Yeah. So 23rd of January, 2018. This issue is resolved. And we worked with them, and they responded fairly quickly, helped sort it out. Of course they would. But Slack rotated all the credentials and fixed the issue. And I definitely don't envy the guys who had to do that. We were rewarded $10,000 for this bug on HackerOne. And this is some of the source code. That's how it looked like.
So there's some of the keys in the source code. So as you can
just straight up hard coded.
Yeah. Cool. So some more examples. Won't go into as much depth. But video game company. This company runs a program that for a time was paying out really well for subdomain takeovers. This obviously led to people focusing on discovering subdomain takeovers. And after a while, this company got sick of paying out a bunch of money for all these takeovers and wrote a tool that would automatically detect and fix subdomain takeover issues, which is great. Tool did an awesome job at finding and fixing these issues automatically. I believe it's open source, right? Really great tool, except our continuous monitoring tools were finding the subdomain takeovers faster than their tool was fixing it by about a few hours. So, it's great that they did it, but again, the kind of continuous security monitoring it and getting that speed, you can pick those issues before they're fixed. Same video game company. So remember the photo of Shubs in the taxi? This is this bug. So when we landed yesterday in London, we reviewed our tools and noticed that this company had exposed a GitLab sign-up page that may have allowed anyone to sign up to their internal GitLab instance. I say may have because it was introduced, found, and then fixed by the company while we were on the flight over here. So we kind of missed it. But even though it's a long-ass flight from Australia, and it really is a long-ass flight, that it was still only exposed for less than 24 hours. So had we not been on a flight over here, we probably would have picked that up, and hopefully that, we would have been able to make some money from that. But you can sort of see now with continuous security assessment, you can find and capitalize on those issues. So what can you do about ephemeral vulnerabilities? So ephemeral bugs are mostly down to pace of change, complexity, and scale. Securing systems that are constantly changing across large and complex attack surfaces is hard. Automation really is the key to helping mitigate these issues. There are many things that you can do on the prevent side. So baking better automated security checks into your development and deployment processes. But in reality, doing that effectively at scale is going to be quite difficult and probably not going to stop all the issues realistically. Shit happens. You saw the kinds of companies that were talking there. They spend lots of money on security. They have talented developers, and it's tough. That's not to say that you shouldn't try doing this, and that's definitely good practice. You should be trying to do stuff on the prevent side. But really, the more realistic approach at scale is to essentially minimize the level of exposure from these ephemeral vulnerabilities. So essentially, you want to make them even more ephemeral. So having a strong handle on your externally facing assets is the first step and critical to helping to stop these issues. If you don't know what you're trying to protect, you won't be able to protect them. Pretty fundamental. And then from there, monitoring all your assets for these types of issues continuously so you can identify and respond quickly as you identify them and they pop up. I know it might seem a little bit like whack-a-mole security, but for ephemeral issues on a large attack surface, it's often the most realistic approach to minimizing the exposure. And that's the end. Any questions?